So now we're looking at, we've been doing integration, or maybe you haven't done integration by the time you look at this, because this is like the precursor to integration, or the slow way to be able to find the area under a curve. But it's important you know how to do this for the AP exam. So I'm going to show you a few ways to be able to find area under the curve without using integrals. Okay, now the question we want to answer, or ask and then answer, is how can we find the area under a curve without integration? Okay, so a few ways. You can use the area of a rectangle to approximate the area between the curve and the x-axis. So how can we find the area under a curve without integration? Use the area of a rectangle to approximate the area between the curve and the x-axis. Okay, so here is our curve. Here is our x-axis. We want to be able to find the area underneath. Now, one way we can do that is to divide it up into rectangles. Okay? Well, so first, divide the region into two rectangles. So in this case, we're going to go from x equals 1 to x equals 2, and from x equals 2 to x equals 3. Now you can see by looking at this, right here and right here, this is our width, right, of each rectangle. And our width of each rectangle equals 1. Now how do you find the height of the rectangle? Like, how would you find the height here or the height here, right? Well, we have a equation that we can just plug that into. So the height of the left rectangle is found by plugging 1 into, so the number 1 into y equals x squared plus 2. So y would equal 1 squared plus 2, which equals 3. So the height at 1 equals 3. Okay, the second rectangle. Okay, now we're doing just the left side. Okay, this is, I'm showing you the left side way. So we'll plug in 2. So y equals 2 squared plus 2, which equals 6. Okay, so therefore the total area is, well, 1 times 3 for the first rectangle plus 1 times 6, which is 3 plus 6 is 9 units. Now, this, as you can see, is a very rough approximation because look how much area it actually ignored. Like all of this area was ignored. So it's just an approximation, and if you see by looking at this one, it should be too low, right? It's missing a lot of area. So just this is a rough approximation. So what would make this better to be able to find out and find out more of that stuff that's missing, right? So that's where we go to, if we cut the rectangles, in half, we'll get a better approximation. We will get a better approximation. Therefore, we would get 4 rectangles. Okay, now we're just going to stick right now to doing the left side, okay? So here is where we're going to find our heights. So you can see that what we did is we took these, right? So we took 2 plus 1 and divided by 2, and you get 3 over 2. We find the average. What's the middle of them, right? And in this one here, we could take 2 plus 3, which is 5, divided by 2, and we get 5 over 2. So this is how we got our new numbers, because that's the average of those two. So now, so we know the width. Now, there's a formula for width as well, and that's b minus a over n. This would be b, and this is a. Those are your two endpoints, and you divide by the number. Okay, so in our case, that would be 3 minus 1 over 4 rectangles would be 2 over 4, which equals 1/2. Okay, so that's our width. Now, how do we find our height of each rectangle? Well, you find your height by plugging your numbers into your x squared plus 2. So if we're finding heights, okay, the first height, if we look over our picture, would be 1 squared plus 2, which equals 3. Rectangle 2, we would put in 3 over 2 squared plus 2. That gives us 17 over 4. 3 would give me, or the third would be 2 squared plus 2, which is 6. And 5 over 2 squared plus 2 would be my last height, which is 33 over 4. So total area now would be taking all of your rectangles and, well, finding all your rectangles, add them all together. So total area, the first one would be, so my width is 1/2 times my height of the first one is 3, plus 1/2 times the height of the second, which is 17 over 4, plus 1/2 times the height of the third is 6, plus 1/2 times 33 over 4, which is 43 over 4, which is approximately 8.25. Okay, so let's come up with a general formula now. So therefore, the formula for area using left end points, so left end points, this is only for when you're using the left end points. Now, it's always width times our heights, right? So our width we found as b minus a over n is how we're going to find our width. And when we have these, this will be our y's will be, this will be y1, this is y2, this is y3, this is y4, oops, y4, and this is actually y5, this one here. Now you see we didn't use y5. So it's always going to be times, now my heights are y0 plus y1 plus y2 plus y3, and it'll always be yn minus 1. So in our case, we had 5 different heights, right? But we're going to count the first one as y0, not y1. Okay? When we do right, as you'll see in a second, that will be y1, and we'll go all the way to y5 in that case. Okay? So, as you can see, this is y, oops, that's not good. I messed that up totally. Sorry. Okay? This is y0, y1, y2, y3, and the last one is y4. My apologies. Okay? So you can actually see there's 5 y's there, starting with y0, y1, y2, y3. Okay? So make sure you make that change on yours as well. Okay? Now, do you see same picture as above, right? But we're going to do this, well, it's not the same picture, sorry, it's the same graph, but do you see that we're going to make all of our y's now the right endpoints, okay? So we got this one, then we have this one, then we have this one, and then we have this one. Okay, so we're going to do this. Right, we've got the, and now we can, that's our length and our width, right? Or our height and our width. So this one is about using right endpoints, using right endpoints. Okay, so our width is going to stay the same because it's the same as above, right? That would be the width is 3 minus 1 over 4, which equals 1/2. Right, so that's not changing. So, but for rectangle 1, we're going to be putting in, so this is y0, y1, y2, y3, and y4. Oops. Just want to make sure it's recording here. Okay, so for this one here, right, this, if we put in 1, we're going to get, this is actually, would give us y0 here. This is y1, y2, y3, and y4. Okay, now when we go to find our heights for rectangle 1, I'm going to use 3 over 2 squared plus 2, which equals 17 over 4. For rectangle 2, I'm going to go 2 squared plus 2 is 6. For rectangle 3, I'm going to do 5 over 2 squared plus 2 equals 33 over 4. And for rectangle 4, I'm going to use 3 squared plus 2 equals 11. Okay, so therefore my total area is going to equal 1/2 times 17 over 4 plus 1/2 times 6 plus 1/2 times 33 over 4 plus 1/2 times 11, and that gives me 59 over 4, which is 14.75. So if you look at the answer above, it's 8.25 because we left a lot of area out. When you look at this one, I should put my approximation there, it's 14.75 because we went and calculated a bunch of area here that really isn't under there. So we would be in excess. But the formula for the right, so when we do total area using the right endpoints, okay, so it's b minus a over n, that's the width, times, not y0, but y1 plus y2 plus y3 plus yn, in this case 4. Okay? So we can just look how those are a little different. We both have a y0 to y4, but in left endpoints you don't use y4, and in the right endpoints you do not use y0. Okay, so now this might be a little better approximation because we're actually doing midpoints. Okay, so this is using midpoints to find area. Okay, so we can also take each one of those other midpoints, or sorry, all those other ones we had. We can find the average of these two, and then find the average of these two, find the average of these, and find the average of these by going 1 plus 3 over 2, divide that by 2. Okay, so I'm going to do the work up here because it's pretty tight down there. So for rectangle 1, the midpoint would be 1 plus 3 over 2 divided by 2, and you get 5 over 4. Now rectangle 2, we would do the midpoint of 3 over 2. Oops, sorry, mid 3 over 2 plus 2 all over 2, and that gives me 7 over 4. Okay, rectangle 3, midpoint, give me 2 plus 5 over 2, all divided by 2, which is 9 over 4. And rectangle 4, the midpoint is 5 over 2 plus 3, all over 2, which would give me 11 over 4. Now, the width is b minus a all over n, which would be 4 rectangles again. So that's still going to give us 1/2. And it should make sense that these are all 1/2 apart. So you can actually just find the first one and keep adding a half, but that might be, you might make a mistake, so it is a way to check it. Okay, now here are going to be our heights. Okay, so those are our heights. So let's find those out. So for rectangle 1, we're going to put 5 over 4 squared plus 2 equals 57 over 16. Rectangle 2, we're going to put 7 over 4 in there. Squared plus 2 equals 81 over 16. Rectangle 3 is 9 over 4. Squared plus 2 is 113 over 16. And rectangle 4 is going to be 11 over 4 squared plus 2 equals 153 over 16. Okay? So, area would equal 1/2 times 57 over 16 plus 1/2 times 81 over 16 plus 1/2 113 over 16 plus 1/2 153 over 16. And when you do this, you get 101 over 8, which would be approximately 12.625. So the general formula would be b minus a over n times y half between intervals plus y 3 over 2 plus y 5 over 2 all the way to y 2n minus 1. Okay, and I think that should be over 2, 3, 5. Yeah, I think that's over 2. Okay, so this just means evaluate 1/2 in between intervals. Okay, so you can find the first interval and you can just keep, like I showed you above, you can just keep adding the width to it and you'll get all the other ones. Okay, now I just want to talk about in general now. Now that we've done all of the different ones, the larger n gets, so that means the more rectangles, right? The more rectangles. Okay, and smaller. Okay, the more rectangles, comma, the better approximation we can get. So, for example, if we were doing left endpoint, okay, we would go as the limit, x, oh, not doing good here, as the limit of n goes to infinity of b minus a over n of y0 plus y1 plus y2 plus y3 plus yn minus 1. The more rectangles you have, the better approximation you're going to get, because there would be less gaps in the... Okay, so you see how we have all these gaps here? Okay, we would have a lot less if we could make those rectangles smaller and smaller. Just need to pause for 1 second here. Okay, let's keep going along. Let's just do some examples here. So approximate the area under the curve y equals x cubed from x equals 2 to x equals 3 using left endpoints. Okay, so if we look down here, our intervals, or our widths, would be b minus a over n, which is 3 minus 2 over 4, which equals 1/4. Okay, so if we're going to use left endpoints, right, now we got to go find our heights. Okay, so our first one, we would put in well, actually, let's assume we don't have all those numbers down there. If I was going from 2 to 3 and I want to do 4 intervals, then I would find my width and I would go 2 plus 1/4, and I would get 9/4. And if I added 1/4 to that, I would get 10/4, which is 5 over 2, right? And then I would add 1/4, and I would get 11 over 4. And then I would add 1/4, and that is 12 over 4, which is 3, right? This is 5 over 2, and that is 3. Okay, so we've got 2, 9 over 4, 5 over 2, 11 over 4, and 12 over 4. Okay, how do we find our area? We need width times length, right? So area equals, our width is 1/4, and what's our height at? Now we're going to be doing this one, y0, then y1, then y2, and then y3. Okay, so 1/2 times 2 cubed plus, 1/4, I think I said 1/2, and then 1/2 times 9 over 4 is my next one, cubed, plus 1/4 times the next one is 5 over 2 cubed, plus 1/2 times 11 over 4 cubed. This would equal 893 over 64, which is approximately 13.953. Okay, so let's do the same question, but we're going to be using right endpoints. Okay, so this is just review with a different question. Okay, so my intervals I got from before were 1/4. That was my width, right? So on this one now, I'm going to be using all my rights. Okay. In fact, you can start from the right if you want, and you can move left as you draw them. Okay, so what do I mean by that? Well, I could, if I'm doing all my rights, I'll start with this one. Okay, then this one, right? And that's the height of that rectangle. Okay, so the intervals, 1/4, so how would I find the area of this? Area equals 1/4 times 9/4 cubed plus 1/4 times 5 over 2 cubed plus 1/4 times 11 over 4 cubed plus 1/4 times 3 cubed. Okay, and that'll give me 1197 over 64, which is approximately 18.703. You see how the one that was left-hand side, it was an under approximation. Okay, this one would give us an over approximation, because you see how much of that shaded, those shaded rectangles are outside the curve. Okay, now let's do one more using our midpoints. Okay, so we have 2, 9 over 4, 10 over 4, 11 over 4, and 12 over 4. If we find the half of each one, the midpoints of each one, so we're going to take this, we're going to add them together, and we divide by 2. Right? Add them together, divide by 2, add them together, divide by 2, and you'll get 17 over 8. Here you'll get 19 over 8. Here you'll get 21 over 8. And here you'll get 23 over 8. Remember, the base width equals 1/4 still, right? We don't have to recalculate that. Okay, so then area equals 1/4 times 17 over 8 cubed plus 1/4 times 19 over 8 cubed plus 1/4 times 21 over 8 cubed plus 1/4, 23 over 8 cubed, which gives me 2075 over 128, and you get 16.211. So as you can see, it's in the middle of the other two, 13.953 and 18.703. It's right in the middle. Okay? So that's just 3 more examples using left, right, and middle. Okay, now this says use the right-handed Riemann sum to approximate the area under this graph between 2 and 12. So this is how we're going to use tables, okay? Because I could just give you a table on the diploma and expect you to be able to find your sum, your area under the curve that way. Okay, so use the right-handed Riemann sum. So first of all, I'm going to label stuff, right? This is y0, y1, y2, y3, y4, and y5. So if we're using right-handed, if we use the right-handed Riemann sum, that means we're going to start with y1, right? Now, the formula is b minus a over n times y1 plus y2 plus all the way to yn, which in our case would be y5. Our width, okay, I have trouble writing today. Our width is b minus a over n. Okay, so we have 5 will be our n, and it's 12 minus 2, which is 10 over 5. Okay, so there's only 5 rectangles. And if you want to, right, so if you think about it, because some people see 6 things, right? But we're going 2, 4, 6, 8, 10, 12. There's the one rectangle, other rectangle, right? So that gives us 5 rectangles. So 12 minus 2 divided by 5, that gives us 2, which you could obviously see, but I just wanted to use the formula. Okay, so we can see what our y's are up there. So if we're doing our integral from 2 to 12, f of x dx, that would equal 2 times 13, because that's y1, plus 2 times 15, plus 2 times 14, plus 2 times 9, plus 2 times 3. And this will give me 108. Okay, now here's another table, but you got to watch. This one's a little tricky. They do not give me nice even intervals. So if you look at our, we've got 2, and we've got 5, and then we've got like 11, then we have like 19, then we have like 22, and then we have 23. Okay, these would actually be a lot closer, wouldn't they, on this? Okay, so our first interval, right, would be, oops, there was a 0. Okay, sorry, from 0, there's 0 there. So our first interval would be 2, our second would be 3, okay, then 6, right, then 11 minus 19, right, we've got 8, and then 3, 22 minus 19 is 3, and then 1. Okay, and that would be 2, and this would have been 3. Okay, so do you see those intervals there? Or you could do them here. That's 2, and this one is 3.
Good afternoon, Eastland. I apologize for the interruption.
Just going to pause this for a sec. Okay, sorry about that. Had announcements. Okay, 3. Then we've got 5, 11. That would be 6 there. This would be 8. This would be 3. And then this would be 1. Okay? And this is going to be considered y0, y1, y2, y3, y4, y5, and y6. Okay, so we are looking for the left-handed Riemann sum. Okay, so the left-handed Riemann sum. So, first of all, our rectangles, we've already figured out the widths of each one. Okay, so how would we find our, well, and then we could see I've got our y's, right? So the first one is going to be 2 high, right? And my, or sorry, y0 is 4. So it's going to be 4 high. What am I talking about? Okay, my width is 2. So you can see y0 is 4. Okay, so if at the very left, okay, this one's going up to about 4. Right, so then I'm going to go, let me write this one out. I got 0, 23, f of x dx. The first triangle I would go, or the first triangle. I've been doing these notes for a while here. This is, my width is, in the first one, 2 times the left, y0 is 4, plus 3 is the next width times the height of y1 is 6. Okay, plus the next width is 6. Okay, and I'm in y2, that's 16. Okay, so that's y0, y1, y2, plus, then I've got 8 is the next one, times, remember left-hand side, right? So that's y3, which is 18. Plus 3 times 22, which is y4. And plus 1 times left-hand side, which is y5, 29. Okay? When you add that all up, you're going to get 361. Okay, so you got to just kind of keep your intervals, and since we're always doing left, right? See how this is on the left side of that one? Then this is on the left side of this one, right? So that's why it would be 3 times y1. Okay, so there's just one more thing I want to show you here, and that is the trapezoid rule. Now, for those of you that forget the trapezoid rule, if you took this right here, actually let me do it in red. Okay, so here's a trapezoid that I can draw. Okay, so there's my trapezoid, right? And if I was to bring that trapezoid out here, right, I could label it. And the way we find is if this is B1 and this is B2, and this is our height. That's supposed to be a B. Okay? Now the area for a trapezoid, which I've shown you right here, is 1/2 B1 plus B2 times height. Now remember, it's on its side, so you can see that the height would be actually the base width, right? Our height will be this right here, and that's our base. Sorry for that. Just had a bit of interruption. So now let's talk about B1 and B2. Do you see that now this is y equals x squared plus 2. So B1 and B2 will be our two. So B1 and B2 will be our heights. And h will be like the width. Oops.
Mr. McBurney, would you call the office, please? Mr. McBurney, call the office.
Okay, will be the width. Now, let's go and find out all of our dimensions. Now the first, this is all nicely evenly spread. So my base will be b minus a, 3 minus 1 all over. There's 4, right, which is 2 over 4, again 1/2. Okay, now our heights. Now let's call this y0, y1, y2, y3, and y4. Let's go find them. So for y0, I have to put in 1 to my formula of x squared plus 2. That's 1 squared plus 2 equals 3. For y1, that's going to be 3 over 2 squared plus 2 equals 17 over 4. y2 equals 2 squared plus 2, which equals 6. y3 is 5 over 2 squared plus 2, which equals 33 over 4. And y4 is 3 squared plus 2, which equals 11. Okay, so now we're going to use our formula for area of a trapezoid because it's just the 4 trapezoids. So it's 1/2 B1, which would be y0 plus y1. So that's going to be 3 plus 17 over 4, all times the base, which is 1/2. So this is half from the formula up here. Do you see that half? Don't get it mixed up. So I'll just label them. This is y0, this is y1, and this is my base. Okay? So plus 1/2 times 17 over 4 plus 6. That is y1 and y2. Plus 1/2 times 6 plus 33 over 4. That is y2 plus y3. Oops, forgot to multiply by 1/2 here. Plus, and then I got to multiply by 1/2 here because that's our base, right? Plus 1/2 times 33 over 4 plus 11, all times 1/2 the base. Okay, it's pretty, so this is y3 plus y4. Okay, so when you put all this in, you'll get 51 over 4, which is 12.75. So the formula for area using trapezoids will be 1/2, right, that comes from the formula, times b minus a over n, that's the base, okay, and then it's going to be y0 plus, now do you see, here's the kind of trick, see there's y0 and plus y1, so that would be plus 2y1, and then I'll have plus y2, so that's plus 2y2 plus 2y3 plus 2yn minus 1 all the way plus yn. Okay, so that is your formula for the trapezoid rule. Now here are all of the
Mr.